Independence Day, the 4th of July, a time to enjoy so much fun food with friends and family and also those fireworks in the sky at night. Joining me now to talk a little bit more about the science of all the aspects of 4th of July is Dr. Mike Evans with the Department of Chemistry at Georgia Tech. Thank you, Mike, for talking to me today.
It's a pleasure.
So let's first dive into the science of food at the grill. Everybody loves a good grilled burger or a hot dog on the 4th. Why do those hot dogs taste so much better with that charring from the grill than if they were boiled on the stove?
Absolutely, absolutely. Well, in boiling, you get a little bit lower temperature. Sometimes it doesn't go on as long, so you don't get these browning reactions um, that turn the burger or hot dog, a little bit brown. And the brown stuff has great flavor. And so from that we get, the savory kind of umami type of flavors from reactions in the burger, in the hot dog, between amino acids and carbohydrates in those foods mostly. They're called Maillard reactions, and they create a lot of those savory compounds that we love in grilled foods. Another thing to note there is that the smoke coming from the grill can also impart some flavor, right? So particularly if you use charcoal rather than propane to grill, you can get some flavor, some smoky flavors from the charcoal burning that a lot of people enjoy.
What if you get out the smoker or the green egg? What's the chemistry behind that versus putting it on a propane grill?
Sure, sure. So smokers in particular are designed to really hold in that smoke and give it a chance to absorb into the meat. And so people will take a long time with those to allow those sort of those volatile compounds in the smoke to absorb into the meat. And then because the compounds are volatile, they evaporate relatively easily. When you take a bite, you really get a lot of that flavor coming off the meat because the compounds evaporate easily. When you use propane, that's a really clean burn, right? It's a very clean combustion. So you're getting a ton of heat out of that, but the byproducts are carbon dioxide and water, and that's pretty much it. So you get much less of that smoky flavor since there really is no smoke when you burn propane per se. It's just carbon dioxide and water.
So what's your favorite? What's your favorite way to grill a nice steak or cook a hamburger?
To me, there's nothing better than over a charcoal grill with that just a little bit of smoky flavor, not too much, but enough that you really notice it was made on a charcoal grill. I also love seeing those grill lines that you get from the contact between the metal and the meat.
Those grill lines are great. Certainly much better than a boiled hot dog on the
Absolutely.
4th. Certainly. Especially watching the Nathan's hot dog eating contest. I'm like, oh, they don't look very good, do they?
I don't know how they do it,
I don't,
honestly.
I don't either. All right, let's turn now to later in the night. As the sun sets, everybody loves to light up the sky with those fireworks, whether it be the sparklers on the ground or those bigger fireworks that are professionally shot off. There's a lot of different colors that we see on the evening of the 4th of July. But there's a lot of science involved with that. I'm going to actually pull up Dr. Evans behind me, the periodic table, and we've got a lot of the different colors that correspond to different elements on the periodic table, right?
Beautiful. Yes, absolutely. So, inside your fireworks, you'll have these compounds that contain these metals. And when you light them on fire, of course, we're giving energy to those compounds. And the atoms have to dissipate that energy somehow. And so, what you see when the firework detonates are those metal atoms like sodium, strontium, barium dissipating the energy. And different atoms gain different amounts of energy and dissipate them in different ways, which is why we see all these various different colors. So, for example, copper, which tends to burn blue, will release more energy than strontium, which tends to burn red. It doesn't exactly correlate with position on the periodic table. It would be nice if it did. It's sort of random, but it's highly predictable. So strontium always burns red, lithium pink, sodium yellow, orange. So we can put known compounds in the fireworks and know exactly what colors we're going to get out.
So if you had to summarize that in like 20 seconds, when we see the different colors in the sky and fireworks, what's
Mhm.
actually happening?
So You light the firework, the atoms inside these metal compounds gain energy, and what you're seeing is those atoms dissipating the energy as heat, which we don't see, but light of different colors. And the amount of energy dissipated depends on the nature of the atom and has an effect on the color you see.
Wonderful. And now I know a lot of us in our neighborhoods might do pretty amateur fireworks, maybe the Roman candles or the little fountains off the ground, the sparklers. But if you go to those big fireworks shows, there's a big boom as they're popping. Is there some science involved in that as well?
To me, it's probably just they're they're bigger. They're just bigger, right? They might use multiple stages. So you'll have multiple compartments with different compounds that maybe one, starts out relatively low energy, and then you get a bit more forceful explosion at the next stage, and then the biggest explosion in the last stage, something like this. But by and large, I think the basic science of those really big fireworks is the same as the ones you would use in your backyard. They just use more and maybe a bit more exotic explosive materials than you might be able to get from your neighborhood fireworks store.
What about the little poppers that you throw on the ground and they make that crack sound? What's going on
Yes,
there?
those use gunpowder, believe it or not. And so what you're doing there is you've got a compound that responds to mechanical force. It hits the ground, picks up energy by hitting the ground and heating up a little bit, and the force of that hitting the ground causes the compounds in the gunpowder to release energy in the form of sound and heat. So very similar principle to the fireworks. It's all about putting energy into the compound and then observing what happens when the compound dissipates that energy. It's just in the case of those poppers, it's sound and a little bit of force. I mean, you'll see them jump, and that jump that you see is the same jump that gunpowder does. It's the exact same principle.
Can we talk about safety of fireworks? You know, when you're in the chemistry lab, you're doing an experiment, you got to wear the safety goggles and all of that. What should people always have in the back of their mind in terms of fireworks safety during and also after they're having fun?
Absolutely. So, with respect to safety with fireworks, probably the number one thing is if you're at or near your house, know where your fire extinguisher is, have your fire extinguisher handy. And you want to make sure it's a fire extinguisher that's appropriate for the fireworks that you're using. Actually, water is not the best thing to put out all fires, and that may be true for certain types of fireworks. So, know where your fire extinguisher is. If you get something that has a remote firing mechanism, absolutely use it. So for these really big fireworks shows, things are remotely triggered and nobody is within 50 feet of the fireworks. If you get to that level where you're helping out with your city's fireworks show or something like that, you want to make sure to use those remote firing mechanisms safely. But the number one thing I would say is know where your fire extinguisher is, have it handy, and obviously, if you've got children around, make sure there's adult supervision in play when you're using fireworks.
And when you're using fireworks, please do not be overly inebriated as well. Be very mindful, level-headed as you're shooting those off. And I always say, douse them in a huge bucket of water, leave them in the huge bucket of water the whole night afterwards, right?
Yes, they do leave residue and litter too, right? So like once your fireworks show is done, look for those little wrappers. Anything that's fallen back down to the ground is a good idea as well. That's also a safety issue because if anything falls to the ground that's still on fire, that's a fire risk.
So we talked about science, we talked about fun, and also a lot of safety on the 4th of July. Thank you so much, Dr. Mike Evans. Appreciate your perspective today.
It was a pleasure.